Okay, in this video, we're going to go through the 2-1 to 2-3 quiz review. So question 1 asks us to describe the pattern that we see, and the numbers are 3, 6, and 12. So the pattern is to multiply by 2. Then I need to get 3 numbers which follow this pattern. So I have 3, 6, 12. 12 times 2 is 24. 24 times 2 is 48. And 48 times 2 is 96. And you can do this math off by the side. That's totally fine. Okay, number 2 says draw the missing figure. So the missing figure is what's missing right here. It's where the question mark is. So I see I have triangle, triangle, cross, question mark, cross, cross, triangle, 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 cross, 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 triangle, triangle. So it looks to me like what I'm missing is the cross. So another, oops, let me just do this easy. Another little cross is necessary. And you can do that kind of cross if you want. Okay, that's what I need, another one of those, and then I'm good to go. So that's the pattern. Okay, find a counterexample to the statement, all dogs have stripes. Okay, so counterexample is something that proves this incorrect. So all dogs have stripes. So I can say, my dog is all black with no stripes. So that would be a counterexample. Okay, so counterexample is find the opposite of what they're saying. Find a counterexample to the statement, the product of two numbers is even. Okay, so we're going to figure this out. If I say 2 times 2, I get 4. Okay, that's even. What about 2 times 3? That gives me 6. That's even. How about 3 times 3? That gives me 9. Bingo. That is not even. That is my counter example right there. Okay, so trial and error, I found a counter example. Okay, so now we're out of the 2.1 and into 2.2. Write the statement in if-then form. Okay, all trumpet players are musicians. So I need to start with an if. So if, how about if I use you? You are a trumpet player. Then you are a musician. Okay, that's an if-then statement, so we're good. Okay, next one. Underline the hypothesis in blue and the conclusion in red. Okay, so the hypothesis does not include the if. It snows tonight. That's your hypothesis. Okay, a lot of times we'll call that P. So then I'm going to change to my red. And the conclusion does not include the then. We won't have school tomorrow. So key thing, don't include if and don't include then. So the conclusion is it snows tonight. The conclusion is we won't have school tomorrow, and the hypothesis was it snows tonight. So let's do the same thing for the next example. If you study for this quiz, then you will do well. So your hypothesis is you study for this quiz. And the conclusion is you will do well. Okay, once again, do not include if with your hypothesis and do not include then with your conclusion. Okay, use inductive reasoning. So inductive is looking for a pattern. So this is pattern reasoning. To finish the statement, Johnny has kicked the winning field goal every time he wears his lucky socks. Johnny is wearing his lucky socks tonight, so he will kick the winning field goal. Now, I don't have the facts about it. That would be deductive reasoning, but inductive reasoning, I look for a pattern and I make a conclusion based on that pattern. Okay, use the law of detachment to make a valid conclusion in the true statement below. Okay, so remember, detachment. You have one if-then statement, and you can then make a valid conclusion from it. Okay, one thing. This should be an angle symbol, and this should be an angle symbol. So you can correct it on your document. Use law of detachment. If two angles are complementary, then their sum is 90. Angle C and angle D are complementary. So their sum is 90 degrees. Or you can say angle C plus angle D equals 90 degrees. Either way, you have used the law of detachment to find a conclusion. If there is bad weather tonight, then the game is canceled. It is raining tonight. So if you assume that raining is bad weather, then you can say, so the game is canceled. That's a valid conclusion. Okay, so that's the law of detachment. Coming to conclusions based on a true statement, true conditional statement. Okay, use the law of syllogism to make a valid conclusion in the true statement below. Okay, with syllogism, what has to happen is this. You have to have a bridge between your two conditional statements. That bridge is that the conclusion of your first conditional statement has to match, in theory, the hypothesis for your second conditional statement. So they first say if water is at room temperature, then it, water, is a liquid. Here's your bridge right here. So I'm going to call this the bridge. If water is a liquid, then it is not frozen. Okay, so you can write a new conditional statement, and that's going to be if water is at room temperature, then it is not frozen. So what did I use to write that? I used the hypothesis of the first conditional statement and the conclusion of the second conditional statement. And since those two conditional statements bridged, I can write the new conditional statement. Okay? So now look at the next one. If a triangle is equilateral, then it is equiangular. If it is equiangular, then all of the angles are congruent. Okay, so if a triangle is equilateral, then it is equiangular. So do I have a bridge? Yes, I do. Okay, so here's my bridge. It is equiangular. Here's equiangular again. Then all of the angles are congruent. So you can write a new conditional statement based on the hypothesis of the first conditional statement and the conclusion of the second conditional statement. as long as you have this identical little bridge. So I can write, if a triangle is equilateral, then all of the angles are, and here's a symbol for congruent. Okay? Okay, so then it says for 10, for the given statement, write the converse. Okay, converse, you switch. Inverse, you negate. And contrapositive, you do both. Then state whether the statements are true or false. Okay, here's your conditional statement. If the shape is a rectangle, so here's your hypothesis, then it has 4 sides. That's your conclusion. Okay, let's write the converse of it. So converse, we're going to switch. And we're going to say, if a shape has 4 sides, then it is a rectangle. What do you think about that? Okay, I think it's false. And the reason why I think it's false is I could draw a parallelogram that has 4 sides, but it's not a rectangle because a rectangle needs to have a right angle in the corners. I can also draw the diamond, and that also doesn't work. So that's why it is false. Okay, the inverse of it, you're going to say not. Go back to the original. If the shape is not a rectangle, then it does not have 4 sides. Okay, and I'm saying, okay, well, what if it's a parallelogram? That still has 4 sides, so it is still false for the same reason the converse was false. Okay, contrapositive. You're going to do both negating it and switching it. So why don't I take the negated one and switch it? Okay, if the shape does not have 4 sides, then it is not a rectangle. Okay, that is true. Only 4-sided shapes can be called rectangles, and if it doesn't have 4 sides, it's not going to be a rectangle. Okay, it says for the given statement, write the converse, inverse, and contrapositive, and then state whether the statements are true or false. So same idea. So if you live in Olney, then you live in Maryland. That's the conditional statement. So the converse, switch it. Oops. Right, switch. I'm going to say that if you live in Maryland, then you live in Olney. And that would be false because I live in Ashton and I live in Maryland. Okay, so then the inverse is going to be not. Go back to the original. If you do not live in only, then you do not live, oops, let me spell that correctly, in Maryland. Okay, that's also false. And now down to the contrapositive where you do both, the switch and the not not. So I'm going to take my not not and switch it. So I'm going to say, if you do not live in Maryland, then you do not live in only. And that is true. Okay, so we got more practice writing the converse, the inverse, and the contrapositive. Okay, so let's think about this. For the following statements, is the conclusion reached through deductive reasoning or inductive? So I said deductive is like being a detective. So let me spell that correctly. Detective. And that is just give me the facts. Okay, where inductive, I'm going to look for patterns. So just look for patterns to reach a conclusion. Okay, so let's read these two statements. Every time we play DeMatha in football, we win. When we play DeMatha this season, we will win. Okay, that looks like patterns. We're seeing a pattern of every year beating DeMatha, and the assumption, or the conclusion that's drawn is that we'll beat DeMatha this season. But that's patterns, so that is induction. Then we have students at GC must wear a GC uniform. A boy at the grocery store is wearing a GC uniform, so he must go to GC. Okay, so this is a fact. This is an observation that's a fact. So therefore he must go to DC is based on facts. So I would say that this is deductive reasoning. So that concludes this review. So if you were successful on that, you should be successful on the quiz in class. Feel free to go back over it. Remember to hit the stop button because I tend to go quickly, but that does not mean that you have to go quickly. You can hit the stop button and kind of figure out what I've said and then go back and listen to it at your pace. Okay, thank you so much.